Okay, this is Algebra 4. Now remember, this is not a task video, okay? This is something that I'd like you to have around for review if you're working on some algebraic expression later on and you're trying to figure out which algorithm you want to try on that particular expression or equation. This is, well, these are the three things that I want you to take a look at, okay? And the three different systems we were talking about yesterday, let me get this to full screen so it's a little easier to see. The three different things I wanted you to see yesterday were one, systematic trial. Okay, that's number one. The second one was working through it through inspection. And the third one, now I guess I'm kind of making the name up here because after all, I'm not quite sure of the name because this is the way I was taught, but I'm going to call this equalization. Okay, and when you get to it, you'll see what I'm talking about. All right. So I'm going to start off with systematic trial. And yesterday we were talking about the same equation. Now, I know you're saying that we've already worked out this equation. It's obvious what the answer is. I know what times 3 equals 36. That's not the point. I wanted to use an equation or an expression in this case that would allow you to not look at trying to get the answer, but look at the way to get the answer. We're looking not at how to get the answer, we're looking at the algorithm, okay? So 3p equals 36. If you were using systematic trial, what you'd really be doing is trying to find a way to, find the number by an educated guess, okay? Let me give you an example. If you wanted to figure out what this is using systematic trial, what you'd first have to do is find a substitute, find a number that to take over for p, okay? If you find a value for p and you try it out that you think is going to be right, hopefully you'll be able to narrow it down until you get the right answer. It's a little bit like using perplexers. So, for instance, if we know that 3p equals 36 is the equivalent of 3 times p equals 36. So if p were 10, I'm thinking, okay, 3 times 10, 3 times 10. Let me just get another pen here because this one stopped working. 3 times 10, well, that's 30, so it's too low. Okay, so then I'm going to substitute p for 20. Okay, just so I can sort of bracket it. Let's see what range of numbers I can use. So if I know that 3 times 10 equals 30, then 3 times 20 equals 60. So that's too high. So maybe I'm going to go for a halfway point between 10 and 20. Maybe I'm going to go for 3 times 15. Well, that's 45, and that's still too high because I have to get down to 36. So the number I'm looking for is somewhere between 10 and 15. So again, I'm going to shoot right for the middle and say 3 times 12. Well, look at this. 3 times 12 is 36. Okay. This will get you the answer if it's a pretty simple equation. But you can see how if you were looking for a number that was in a much more complicated equation, or better yet, if you were looking for a number that was either a fraction or a decimal, you could be at this for quite a while as you bracketed in and tried to find exactly what that number was, okay? So the next way to do it is through inspection. And inspection, what you're really doing is you're using your mental math. If you're good at that, if you've got a good memory for numbers and a good memory for products and sums and all that other kind of stuff, you shouldn't have a problem with this. If the answer is 3, or if the equation is 3p equals 36, and you know that 3 times 12 is 36, well, looky here, you got the answer. Now, this is all fun and good. The problem with the first two systems is, number one, with systematic trial, what you're really doing is you're guessing all the way around. The second one on inspection is you're assuming that you know what the math is. And for most of you, 3p equals 36, you've been able to figure it out, no problem. However, if it got much more complicated than that, relying just on mental math won't help you. You got to find a way to be able to figure this thing out, both at this level, where it's nice and easy, where the math works out nicely, to other situations where it gets a little more complicated. So I'll give you an example of what I mean. What I'm going to suggest to you is equalization. Okay? Now, this requires a few more steps, but no matter what happens, you're going to come up with the right answer. So if it's 3p equals 36, what you want to do is put the letters on one side and the numbers on the other side. Okay, opposite though. You want to have all the numbers on this side. On the right-hand side, you want to have all the letters on this side. And the question is, how do I do it? The other thing is, if you're going to flip numbers and letters across the equal sign, you have to flip to the opposite operation. So if it's a plus on one side, it's got to be a minus on the other side. If it's a divide on one side, it's got to be a multiple on the other side. So when it comes to 3p equals 36, what you have to do is get this number on that side and keep this letter on this side. So you're trying to figure out what p is equal to. P is equal to 36, but because you multiplied p on this side, you've got to divide it on this side. 36 divided by 3. Now, to make this a little more clear, if this is a multiple here, if that is a multiple, that means you're taking whatever our variable is, whatever the value of p is, and you're multiplying it by 3. So in other words, by the time it gets to here, you've multiplied your variable by 3. In order to find out what just 1p is, you've got to divide it by 3. Does that make sense? See how clear that is? Now, if it isn't clear, we'll talk about it more in class, but this is your next step. So p equals 36 divided by 3, which means p equals 12. Now, to make it a little more complicated, okay, if your equation was 3p plus 10 equals, and I'm just making this number up, okay, so I haven't pre-planned it, 56. Well, you want to eventually get down to what the p is, and you want to have all the numbers on that side. So 3p would equal to 56 minus 10. See why? If I flip the 10 over to this side, I've got to take it away from the 56. Okay? As soon as it goes to the other side, it becomes a reverse operation. Therefore, 3p equals 46. Now, I still don't know what the value of p is. So, in order to get to p, I have to do 46 divided by 3. Okay? You with me so far? Okay. So, 46 divided by 3. 3 goes into 4 once. Once it's 16. 3 into 16 goes 5 times, which is 15. Carry the 1, and then 0, and it's actually 15 point, say, 3. Okay, 15 and a third. Okay, so p is equal to 15.3. Okay, I mean that's just a quick way of showing you that, but you can see how this way you're going to get the answer each and every time. If you use inspection, not necessarily the case. If you use systematic trial, you'll get to the answer, but it's going to take you forever depending on how complicated the number is. All right? So try all three. Whatever works more comfortable for you is the one you should be looking at. But keep an eye on what works for you, what doesn't work for you, but also what the positives and negatives of each one of those algorithms are.